Hello students, this is Shachi. Welcome to my channel Track Chemistry. In today's session, I am going to discuss a class 10th topic. Name of the topic is neutralization reaction and chapter's name is acids, bases and salt. Students, this neutralization reaction I am going to explain with the help of NCERT problem number 14. After explaining NCERT problem number 14, I am going to discuss first 10 exemplar problems. Students, before starting, I want to remind you to subscribe my channel and press the like button if you like this video and share this video with your friends also. Now come with me and let's crack chemistry. I'm going to start a discussion with NCERT problem number 14. Problem number 14 is that what is a neutralization reaction? Give two examples. Students, when acid and base react together, the products formed are salt and water. Such a reaction between an acid and base is called as a neutralization reaction. So you can see here when an acid and a base react together, the products formed are salt and water. Such a reaction is called as neutralization reaction. Now they are asking you to write two examples of neutralization reaction. Students, as we have seen just now that the neutralization reaction is the reaction between an acid and a base. So we can write the reaction between any acid and a base. So in the first example, I'm writing the reaction between sodium hydroxide, which is a base, and hydrochloric acid, which is an acid. When sodium hydroxide and hydrochloric acid react together, neutralization reaction will take place. The products formed will be salt and water. Salt formed here is NaCl, its name is sodium chloride, and water is also formed. So this was the first example. In the second example, I can take another base and acid. So this time I am taking calcium hydroxide. Students, calcium hydroxide is a mild base. Its formula is CaOH taken twice. When calcium hydroxide combines with an acid like HCl, the products formed will be salt and water. Salt formed here is calcium chloride. Its formula is CaCl2 plus water will also be formed along with salt, which is calcium chloride. So you can see that this is our balanced chemical equation. CaOH taken twice plus 2HCl. The product formed are CaCl2 plus 2H2O. So the first reaction is the reaction between sodium hydroxide and HCl. The products formed are salt and water. Salt is NaCl and water is H2O. In the second example, I have written the reaction between calcium hydroxide plus hydrochloric acid. The products formed are calcium chloride and water. Students, you must be knowing that calcium hydroxide is also called as slaked lime. It is used for whitewashing and to detect the presence of carbon dioxide. Now, another very important point is the neutralization point. Students, when acid and base react together, neutralization reaction takes place. At neutralization point, the solution will neither be acidic nor basic. The solution will become neutral. So you can see here, this is the neutralization point. Neutralization point is the state where the substance loses its acidic or basic nature and becomes neutral. Students, after discussing NCERT problem number 14, I am going to discuss first 10 exemplar problems. First example problem is that what happens when a solution of an acid is mixed with a solution of base in a test tube. So just now we have learned about neutralization reaction. So you know that when an acid and base mix together, neutralization reaction will take place. And this neutralization reaction is an exothermic reaction. Being an exothermic reaction, the temperature of the solution will increase. So this point I am writing here. Neutralization reaction is an exothermic reaction. So we will consider each option one by one. Option first is the temperature of the solution increases. So this option is correct because neutralization reaction is an exothermic process. Then second option is the temperature of solution decreases is a wrong option. Third, the temperature of the solution remains the same. This is also a wrong option. And fourth option is salt formation takes place. Student, this is the correct option. So option first and fourth both are correct. So we can see here option D is the correct option. So after discussing this question, you must be clear that what is a neutralization reaction? And neutralization reaction is an exothermic reaction, as a result of which the temperature of the solution will rise. Now we are going to discuss exemplar problem 2. Exemplar problem 2 is that an aqueous solution turns red litmus solution blue. So students, if an aqueous solution is turning a red litmus solution blue, it means this solution is basic in nature because bases turn red litmus blue. Now, excess addition of which of the following solution would reverse the chain? So you know that this question is also an example of neutralization reaction. You have to reverse the change, means you have to add the substance which is acidic in nature. So an acid will neutralize a base. So we will consider the given options one by one. First option is baking powder. Students, you know that baking powder consists of sodium bicarbonate along with a mild edible acid like tartaric acid. So baking powder itself is a base. It cannot reverse the process. So first option is the wrong option. Then we will see second option is lime. The students lime is calcium hydroxide. This is also basic in nature, cannot reverse the chain. So second option is also a wrong option. In fact, if we add base to the given aqueous solution, the basic strength of the given solution will increase. Then third option is ammonium hydroxide solution. Students, ammonium hydroxide has the formula NH4OH. It is also a base, so it cannot reverse the process. In fact, it will increase the basic strength of the solution. Now we will see the last option. Last option is hydrochloric acid. We know that hydrochloric acid is HCl. So being acidic in nature, it will cause the neutralization of the basic solution and will reverse the chain. So our correct option is hydrochloric acid, option number D. Now question number third. Students, they are asking in question third, during the preparation of hydrogen chloride gas on a humid day, the gas is usually passed through the Gar tube containing calcium chloride. The role of the calcium chloride taken in the Gar tube is students, the role of calcium chloride taken in the Gar tube is to absorb moisture from the gas because hydrogen chloride gas get dissolved in water and form hydrochloric acid. So option C is the correct option. Now next question. Which of the following salt doesn't contain water of crystallization? Students, you have been given the option. So first of all, we will see what do you mean by water of crystallization. Students, water of crystallization is the fixed number of water molecules present in one formula unit of the salt. Now we will consider the formula of the given salts one by one. Students, first option is blue vitriol. It is copper sulfate pentahydrate. It has 5 H2O molecules in the form of water of crystallization. Its formula is CuSO4.5H2O. It means first option is the wrong option. Then second, they are asking baking soda. The students, baking soda is sodium hydrogen carbonate. It is also called as sodium bicarbonate. Its formula is NaSCO3. You can see that it has no water of crystallization. So correct option is option B, which is baking soda. We can consider the remaining options also. Option C is washing soda. Students, washing soda is sodium carbonate decahydrate. Deca means 10. So its formula will be Na2CO3.10H2O. It means option C is also a wrong option. Now we will see the option D. Option D is gypsum. Students, gypsum is calcium sulfate dihydrate. Its formula is CaSO4.2H2O. So our correct option is baking soda, whose formula is NaSCO3 and it has no water of crystallization. Next is exemplar problem fifth. So here they have given you sodium carbonate is a basic salt because it is a salt of. Students, you know that the salts are formed by the reaction between an acid and a base. The salt which is formed by the reaction between a strong acid and a weak base will be an acidic salt. And the salt formed between a weak acid and a strong base will be a basic salt. And the salt formed between a weak acid and a weak base will be a neutral salt. And the salt formed between a strong acid and a strong base will also be a neutral salt. Now we will see the nature of the given salt, which is sodium carbonate. Students, formula of sodium carbonate is Na2CO3. It is formed by the reaction between NaOH, which is a strong base, and a weak acid, which is carbonic acid H2CO3. So we can see that sodium carbonate is a basic salt because it is a salt of NaOH, which is a strong base, and H2CO3, which is a weak acid. So we can conclude that sodium carbonate is a basic salt because it is a salt of a strong base and weak acid. So correct option is option D. It is a salt of weak acid and a strong base. Now question number 6. Students, question 6 is that calcium phosphate is present in tooth enamel. Its nature is basic, acidic, neutral or amphoteric. First of all, we will discuss about the nature of tooth enamel. Students, tooth enamel is made up of calcium hydroxyapatite, which is a crystalline form of calcium phosphate. It is the hardest substance in the body. Now we will discuss the nature of calcium phosphate. Students, calcium phosphate is a salt which is formed from calcium hydroxide and phosphoric acid. Phosphoric acid is a weak acid and calcium hydroxide is a slightly stronger base. Now it's clear that calcium phosphate, which is formed from a weak acid, which is phosphoric acid, and a slightly stronger base, which is calcium hydroxide, therefore its nature will be basic. So option A is the correct option. Now next is exemplar problem 7. The problem is that a sample of soil is mixed with water and allowed to settle. The clear supernatant solution turns the pH paper yellowish orange. Students, if the clear solution turns the pH paper yellowish orange, it means the nature of the soil is acidic. Then they are asking which of the following would change the color of this pH paper to greenish blue. So, greenish blue means the nature of the solution should be slightly basic as the sample of soil is acidic in nature. In order to make it basic, you have to add some base in it. So we will consider the given options one by one. Option A is lemon juice. We know that lemon juice consists of an acid, which is citric acid. So addition of lemon juice to soil will increase the acidic strength only. So this is not a correct option. Option B is vinegar. Students, we know that vinegar is acetic acid. So addition of vinegar will further increase the acidic strength. So this is also a wrong option. Next option is common salt. Students, common salt is NaCl, which is a neutral salt. So addition of common salt to water will not change the acidic or basic strength, will not change the pH of the soil. So this option is also a wrong option. Last option is an antacid. Students, an antacid is basic in nature. So on addition of an antacid, which is basic in nature, pH of the soil will increase and the color of this pH paper will change to greenish blue. So correct option is option D, which is an antacid. Now question 8. Question 8, they are asking which of the following gives the correct increasing order of acidic strength. Students, we will consider each option one by one. First option is water. We know that water is neutral in nature. Then acetic acid is a weak acid. After that, we have hydrochloric acid, which is a strong acid. So in option A, the acidic strength which is given here is correct. We will consider the remaining options also one by one. Option B, you can see they are giving water. After that, hydrochloric acid. But after hydrochloric acid, they have given acetic acid, which is a wrong option. Then we will see option C, acetic acid. Then they are giving water. This is also a wrong option. Then they are giving hydrochloric acid, then water, then acetic acid. This is also a wrong option. So students, correct option is option A. Now, exemplar problem 9. That if a few drops of a concentrated acid accidentally spills over the hand of a student, what should be done? Student, this is also an application of neutralization reaction. If a few drops of concentrated acid accidentally spills over the hand of a student, we must wash our hand immediately with plenty of water. And in order to neutralize the effect of acid, we must use a mild base. We will consider the given options one by one. First option is wash the hand with saline solution. Student, this is not going to give any relief to the student. So this is not a correct option. Option B is wash the hand immediately with plenty of water and apply a paste of sodium hydrogen carbonate. Student, sodium hydrogen carbonate is baking soda, which is a weak base. So this treatment will give relief to the student because here the student is washing the hand immediately with plenty of water and is applying a paste of sodium hydrogen carbonate, which is a weak base. So sodium hydrogen carbonate being weak base will neutralize the effect of a strong acid. So option B is the correct option. We will consider other options also. Option C is after washing with plenty of water, apply solution of sodium hydroxide on the hand. Students, this is not a correct option because sodium hydroxide is a strong base and you cannot apply a strong base to your skin directly. So option C is the wrong option. Then option D, neutralize the acid with a strong alkali. Again, this is a wrong option because we cannot apply strong alkalis on our skin because they are corrosive in nature. So correct option is option B. Students, the last question is that sodium hydrogen carbonate when added to acetic acid evolves a gas. Which of the following statements are true about the gas evolve? So students always remember that metal carbonates and metal bicarbonates are basic in nature. So when they are treated with acid, the products formed are salt, water and carbon dioxide gases evolved during the process. So in this question, the evolved gas is carbon dioxide. Now we will consider the given options one by one. So option one is that it turns lime water milky. It's a correct statement because when CO2 is passed to lime water is turned milky due to the formation of calcium carbonate, which is insoluble in water. I'll write the reaction involved also here. So lime water turns milky here because of the formation of calcium carbonate, which is insoluble. Being insoluble, it will make the solution turbid. So first option is the correct option. Then option second is it extinguishes a burning splinter. Students, you all know that carbon dioxide is not a supporter of combustion. Even carbon dioxide is used in fire extinguishers to put out the fire. So option second is also the correct option. Option third is it dissolves in a solution of sodium hydroxide. Students, option third is also a correct option because CO2, carbon dioxide, is an acidic oxide. Acidic oxide will react with the base like sodium hydroxide. So it will be a neutralization reaction and products formed will be salt and water. So I am going to write reaction involved here. NaOH plus CO2. Products formed will be sodium carbonate plus water. It's a neutralization reaction. So two molecules of sodium hydroxide will take part here. The product form will be Na2CO3 plus H2O. So option third is also a correct option. Then option fourth is it has a pungent odor. Students, carbon dioxide is a colorless, odorless gas. So option fourth is a wrong option. So the correct options are options first, second and third. So you can see that option B is the correct option where it is given that option first, second and third. And remember that carbon dioxide is a colorless, odorless gas. So our correct option is option B. Students, thank you so much for watching this video. I hope each and every point is clear to you. Please subscribe my channel and like this video in case you like it and share this video with your friends also. Don't forget to watch my next video. Thank you so much. Have a nice day.